this subsection, we'll formally define the third type of quantified statement, the universal conditional statement. Through examples, you'll get a chance to learn how to translate a variety of quantified English statements into the fully symbolic form of universal conditional statements. In the previous subsection, you learned about the universal and the existential statements. In this subsection, we will learn more about the universal conditional statements. First, some definition. Suppose we have P of x and Q of x as predicates, and set D as the domain of x. A universal conditional statement comes in this form. It is read as, for all little x, if P of x is true, then Q of x is also true. How do we tell that a statement is a universal conditional statement? Look for the for all symbol, which indicates universal coverage, but this time, provided the condition P of x is met. If given a semi-symbolic statement like this, for all staff x in the company, if x breaches the contract, then x will be fired. What does it mean to you in English? If you have any of these translations, they are acceptable. In this example, the instruction is the same as the two previous subsections, except that we want it to be in the form for all something something, if something something, then something something. That's really the universal conditional statement. Where do we begin? In the statement, all turtles have long lives, the key word is all. So step 1, introduce the quantifier by changing the all to the for all symbol. Next, step 2, we introduce a predicate variable x. In the universal statement and existential statement, we had to see who x was referring to. But here, for universal conditional statement, we do not need to do that. Nail down the x straight away by saying, for all x. Then do a conditional check to see if x is a turtle. If x is confirmed to be a turtle, then what happens to x? Well, then x has long life. And that's the semi-symbolic form. Great. Let's dwell further to get the fully symbolic form. For steps 3 and 4, instead of defining one set and one predicate, we define two predicates. The first predicate should follow the if part of the semi-symbolic statement. For our case, we define the first predicate T of x to be x is a turtle. The second predicate should be taken from the then part of the semi-symbolic statement. In our case, we define the second predicate L of x to be x has long life. Finally, we can put all the symbols together. Focus on the semi-symbolic statement again. Keep the for all x symbol as it is. If x is a turtle, can be replaced by the predicate T of x. Then can be replaced by the symbol right arrow. And x has long lives can be replaced by the predicate L of x. That is the fully symbolic form. Check that you have defined two predicates for this situation. In this statement, no is the key word that can be interpreted as all or not. So step 1, introduce the quantifier for all symbol. Step 2, we introduced a predicate variable x. Then do a conditional check. What do you need to check? We want to check if x was a resident in the small town. If it's confirmed true, then what happens to x? Well, then x was not spared by the tornado. and that's the semi-symbolic form. Okay, let's move on by defining the two predicates. The first predicate should follow the if part of the semi-symbolic statement. So define R of x as x was a resident in the small town. The second predicate should follow the then part of the semi-symbolic statement. So define T of x to be x was spared by the tornado. Finally, we can put all the symbols together. Focus on the semi-symbolic statement again. Keep the for all x symbol as it is. If x was a resident in the small town, can be replaced by the predicate R of x. Then can be replaced by the symbol right arrow. And x was not spared by the tornado can be replaced by the predicate not T of x. That is the fully symbolic form. Check that you have defined two predicates for this situation. Since if-then statement has an equivalent for all format, we'll do step 1. Introduce the quantifier for all. Step 2. Introduce a predicate variable x, then do a conditional check. What do you need to check? Well, we want to check if x is a job seeker who is also an IT specialist. If it is confirmed true, then what happens to x? Well, then bank B wants to hire x, and that's the semi-symbolic form. Now, let's move on to define the two predicates. The first predicate should follow the if part of the semi-symbolic statement. So define S of x as x is a job seeker who is an IT specialist. The second predicate should follow the then part of the semi-symbolic statement. So define B of x to be bank B wants to hire x. Finally, we can put all the symbols together. Focus on the semi-symbolic statement again. Keep the for all x symbol as it is. If x is a job seeker who is an IT specialist, can be replaced by the predicate S of x. Then can be replaced by the symbol right arrow. And bank B wants to hire x can be replaced by the predicate B of x. That is the fully symbolic form. In summary, universal conditional statement is of the form for all x, if P of x is true, then Q of x is true. If-then statements fit particularly nicely into this form. Any statement with keywords such as all or the like can be transformed into this form by changing the set that x belongs to into an if condition. No is interpreted as all are not, hence can be transformed into a universal conditional statement by using the if condition. To get to the semi-symbolic form, introduce the quantifier and the predicate variable for all x. In order to get to the form, for all x, if x is something something, then x is something something. To get to the fully symbolic form, introduce two predicates, P of x and Q of x. In order to get to the form, for all x, if P of x, then Q of x.